Assalamu alaikum. Welcome to our new presentation. Today we are going to present you DC power supply. First, you see about sequence that how we are going to study the DC power supply. First, we are going to introduce you the working of DC power supply. Then we are going through the equipments we needed, then also discuss the circuit diagram and at last the conclusion. So firstly I am going to introduce you about the DC power supply, that why we need DC power supply. The electrical power is almost exclusively generated, distributed and transmitted in the form of alternating current because of many economical considerations, but operation of most of the electronic devices and circuits DC supply is required. Nowadays we are using dry cells, batteries for this purpose. No doubt they have advantages that they are portable and triple free, but their voltage are so very low. They need frequent replacement and are expensive in comparison to conventional DC power supply. Moving next to the working. First, voltage step down process, AC to DC. The voltage would down by the transformer. The working principle of transformer is very simple. It depends upon Faraday's law of mutual induction between two or more winding is responsible for transformation action in an electric transformer. The next point is rectification process. Rectification process will be accomplished by using a diode. A diode is an electrical component that conducts current in one direction and blocks current from flowing in the other directions. Filtering process. Here we use a capacitor for filtering our output. A capacitor is commonly used for filtering and stores charge in it. Then we also use load. We use LED light for our project as a load, and then resistor. Resistor is an electrical component that reduces the electric current. So now moving to the equipments we needed. First of all, we need a project board, a transformer, 4 diodes, a resistor, capacitor, a load, and connecting wires as needed. So now we are going to check the circuit diagram. This is a circuit diagram on which the project would work. First, we have a 220 volt alternating current source, then a transformer, 4 diodes, then a capacitor, 2 resistors, and at the end a load LED. So after completion, the project looked like this in a pure working condition, and it's also on now, working properly. So moving to the conclusion, the power supply that has been designed provides a good alternative to a more expensive power supply. The power supply has few components, covers a small area, and is very simple in design. Now we are going to check some of the problems or resolve some circuits. In this circuit, we have to determine a voltage and three currents. A current in R1 and in two diodes, and also find the voltage across D2. For the applied voltage, the pressure of the source is to be established a current through each diode in the same direction. Since resulting current direction matches that of the arrow in each diode symbol. So as we know that in forward bias, the silicon diode in practical model drops 0.7 volt of current. So the voltage across D2 is V0 and which is equal to 0.7 volt. Now we are going to find the current which is I is equal to V over R. Here we find V E minus VD. The value of E is 10 volt and E is the main supply we are giving. So E minus VD, the voltage across the diode. Here the I1 comes is 28.18. Assuming diodes of similar characteristics we have, so both the diodes have same current because they are in parallel according to KCL, Kirchhoff current law. The current divides in both diodes 14.01 and 14.01. Moving next to the Proteus simulation we have. This we have for our verification process. Proteus is a calculator basically. It calculates us that the current is at this point is 28.2 and then it divides in two diodes like this 14.1, 14.1. Moving next to our next problem. Here we are going to determine two voltages and a current. So first we are going to find a voltage V is equal to RL VI over R plus RL, which is equal to 8.73 volt. Since VL is less than VZ, the zener is off and act like open switch. Moving to the next part of the same question, we again find the voltage, but here the resistance of load is 3K and the voltage we have is 12 volt. Now V is greater than VZ, zener is on and VL become equal to VZ, which is equal to 10 volt. So VR is equal to VI minus VL, which is equal to 16 volt minus 10 volt and which is equal to 6 volt. Now we are going to find IL and IR. IL is equal to 3.33 milliampere and IR is equal to 6 milliampere. And at last we find IZ, which is equal to IR minus IL. IZ is equal to 2.67 milliampere. So P is equal to VI. At last PZ is equal to 26.7 milliwatt, which is the power. We again here do some Proteus work for the verification process and it's verified successfully. The previous one is with resistance of 3K and this one with a resistance of 1.2K. Thank you for watching this video. Allah Hafiz.